All right, so we are looking at, I think it's worksheet 9. Yeah, 9A. And what I'm going to have you do is we're going to think about the unit circle and the ordered pairs that are on the unit circle. Now, what is the radius of the unit circle? Remember here? It's 1, yeah. So the whole point of it being a unit circle is that the radius is always a 1, and then it creates this really beautiful trig function when you graph it. And what I want to do first is look at the function for sine. So if you think about on the unit circle, which is that guy. I do have all my unit circles, right? Okay. Which part of the ordered pair on the edge of the unit circle refers to the sine function? The y, yes, the y values. So all of these guys are the sines. And then what we're doing is when we're plotting along the coordinate plane, which we're about to do, it's the radian measure is now the x-axis. So 0 radians, pi over 6 radians, and so on and so on. Now, we're only plotting certain points. And for like me in particular, when I plot them, I only plot the quadrantals, the quarter points, which we're going to call today. So let's look at this picture. Whoops, not that picture. This picture on your notes. And let's talk about the sine function you guys told me was the y value. So at 0, what's the y value? 0. So that's why when you're plotting the sine function, it's starting here at 0, 0. So what you're doing technically, like, you know, I'm not going to be able to draw a straight line, so here we go. You're supposed to be measuring the heights of all of these ordered pairs that fall along the curve. Oh boy. Yeah. So here's what's going to happen. There's no chance that I'm going to be able to graph that many points well. So what I'm going to do is I'm going to specifically graph the quadrantals, because those I like. So we just plotted, this was, you told me 0, 0. What's going on up here? What's the radian measure for this ordered pair? Pi over 2. But how tall would this red line segment be? 1 unit, good. So let's pretend that's a 1. Okay. So basically the curve's going like this. It's increasing, increasing, increasing. What's going to happen to the lengths of the red line segments as I move along this way? They're going to shrink down, 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 down until you get to 0. Now, when does that 0 occur? What is the quadrantal angle over here? This was pi over 2. This was pi. So this mark right here is pi. Now, the lengths, or the y values, of what I'm now going to call the blue lines. Those are supposed to be vertical. I'm doing a bad job. They're getting bigger and bigger and bigger and bigger, but towards what value? The biggest quote they get, which is actually smallest, is down to -1. And that happens at 3 pi over 2. So if I keep moving along here, if I call this 3 pi over 2, our function kept going lower and lower and lower and lower until it hit -1. Awesome job, Bruzo. That's the worst graph ever. Believe it or not, I'm actually really good at graphing trig functions. Just not today, apparently. And then if I continue on to the next quadrant, these blue vertical lines, totally vertical, this time they're going to get, you know, closer and closer and closer and closer back to 0. And when do they hit back at 0? Back here at 2 pi. So the sine function is basically measuring the heights of all of those little, what are supposed to be vertical line segments, as it goes through the curve from 0 to 2 pi. That's sine. I think you already knew that. When you guys first were introduced to the sine function versus the cosine function, probably in your algebra 2 brain or eventually your trig brain, you just said, okay, sine's the one that starts at 0, cosine's the one that starts up at the top. And we'll talk about why cosine is that in a minute, but let's bring back an old concept. Is sine even or odd? Now, I didn't continue on graphing the sine function, that's just one cycle, but we know it would have dipped down like this, and then came back, and then went back up. So think about symmetry. If it's even, it has y-axis symmetry. If it's odd, it has symmetry of the origin. What you got here? This is your origin, by the way. It's got symmetry of the origin. So it's odd function. So sine was graphing the heights. That means cosine is going to graph the horizontal components of it. But you guys already knew that from your unit circle. The x value on the unit circle were all your cosine function values. So this time, let's see if I can graph better. I'm going to start measuring how far out horizontally all these little red pieces are. So this first red piece that I tried to draw, that's at 0 radians. But what was the length of it on the unit circle? It was 1. Okay, Abruzzo. Graph. There we go. 1. And then they keep getting smaller and smaller and smaller and smaller until they hit over here at pi over 2. What is the length of the red one up here at pi over 2? I got nothing. This is going to be really ugly. Okay, and then some more red lengths here. This time they're going to get bigger and bigger and bigger and bigger. Yeah, and so on. Until they get all the way down to here, which is at pi. But the lengths of these red segments, because they're traveling left now, they're getting bigger, but they're not really getting bigger. They're getting smaller because they're going close to what value? How big does it get down here? -1. Oh boy, that's not, oh, chippers. Okay, so I didn't draw anything that looked right there. Let's try this again. I just got done bragging about how good I can draw cosine and sine, and this is what I'm doing today. This is awful. Okay, 3 pi over 2. When I travel to the next quadrant, talk to me about what's going to happen with these segments. Let's see. They're going to go back and approach 0. And then, here they go again. Now they're getting bigger and bigger and bigger until they approach back at 1, which is going to hit us all the way up to pi over 2. Okay, there we go. Totally. This is exactly what it looks like, Abruzzo. Good job. Gosh, it's terrible. Is that what cosine's supposed to look like if you squint? It's the horse. I call it the horseshoe shape. That's what I learned when I was little. But cosine is the trig function that starts up at the maximum value for its range, unless it's been reflected. Talk to me about symmetry here. So this is only half of this part, right? It would have come back down and done this. So this guy has symmetry of the y-axis. So is this an even function or an odd function? This is an even function. Symmetry of the y-axis. That's not just a random question. I mean, it's nice to bring back old concepts, but we're going to come back to the idea of these being even and odd because we're going to need them later. All right, and then tangent. Tangent you can't actually see on the unit circle because remember tangent is a ratio. Tangent is the slope as theta changes in radians. So you guys know tangent as the sine function over the cosine function. But if you think about what slope means, it's y over x, which is exactly what tangent is. So let's talk about the slope of starting here at 0 radians. What is the slope of a line segment that just goes straight across like that? 0, yeah. So here's 0 radians. And your tangent function has a slope, well, the unit circle has a slope of 0 right there. And then think about what's going to happen if I start making little line segments. Describe for me what's happening to the slope of each of these green line segments as I approach the next quadrantal. It's getting steeper or bigger until it hits the next quadrantal. What is the slope of a line that's completely vertical? Undefined. Okay, so the slope was getting bigger and bigger and bigger and bigger. But when I go to graph something that's undefined, like we're going to have here at pi over 2, an undefined value on a graph means you have a vertical asymptote. So when you're graphing a vertical asymptote, you just kind of draw a little highlighter or dashed line, and it shows you that there's an asymptote there. Now this is kind of tricksy. I'm going to go backwards. I'm going to measure backwards, which means I'm measuring back to negative pi over 2. We'll say is right here. What's happening to the slopes of these green lines as I travel backwards like this? They're getting more steep. However, they're getting steep in a negative direction. So they're doing this. And then what happens when they hit pi over 2? Negative pi over 2, excuse me. At this value, it's undefined again. So you're going to have another vertical asymptote. So I just drew the ugliest tangent function you've ever seen in your life. Oh my gosh. There we go. A little better. That is one cycle of your tangent function, and then we know they're cyclical, so they repeat a bunch. Tangent stinks. No one likes graphing tangent. In PreCalc, we'll be graphing sine, cosine, tangent, secant, cosecant, and cotangent. Because we're better than that, right? For now, we're just going to graph sine and cosine. In fact, today, I'm only going to graph things that I don't even have any shifts happening today. So there's no phase shifts, which are the hard ones that go right and left. I don't even think we have vertical shifts today. So today's an easy graphing day, easy intro day. Oh, by the way, tangent. Do you feel like this is an even or an odd function? It is odd. Very good. Again, we have symmetry of the origin. Good deal. All right. Oops. Next page. Can you find worksheet 10? Now I'm going to warn you. My file that I have for worksheet 10 is not looking the same as yours for some reason. So that was my bad. We'll have to skip around a little bit on my file. We're basically going to do a couple problems off the front of worksheet 10, and then we're going to leave the rest of the lesson for Monday. Graphing is not on your test next week, but it's going to take us a few days to get through the graphing lesson, because if you guys remember graphing trig functions, it gets pretty exciting. We graph with boring graphs at the beginning. We graph with phase shifts after that. Then we got to do application questions, which are always a hoot. And then we got to come back and graph all the weird ones like secant and cosecant. So on your salmon colored sheet, I think you have some variation of these properties that you get to utilize anytime you're graphing for me on a test. But on your notes, let me know if it's different, but I feel like you have this on your notes somewhere. Yes. Oh, cool. Okay. So a couple of important points for us today, guys. The amplitude, whoops. When we do applications, we're going to learn that, or relearn, that the amplitude is the measure for like the power of the wave. But in the formula, the A value, if you take the absolute value of that, that's the amplitude of your curve. Now, amplitudes are never negative. So if there's a negative number in front of your function, don't tell me the amplitude is -3. That's not correct. The negative does something. What does a negative in front of a function do? It reflects it. Yeah. So it is pertinent to the graph, but it doesn't affect the size of the amplitude. The period can be calculated by 2 pi divided by b. Now they put absolute value bars around b because technically you can have a negative b value, which also reflects it across the y-axis this time. But don't worry about that. We're not going to get crazy and give you negative b values in PreCalc. So 2 pi divided by b is the same formula you used in Algebra 2 and also in Trig to find the period. We'll come back to the idea of frequency once we start doing applications, so don't worry about it for now. We'll come back to the idea of phase shifting next week. We'll come back to the idea of vertical shifting next week. The only other thing you might want to write down in your notes is, because of the way I graph, I'm going to encourage you guys to find quarter points. Now this is specific to sine and cosine. The reason I want you to find quarter points is because those would be the quadrantal angles, which gives you like little marks along your graph so you can actually graph well. AKA so I can graph well. So to find the quarter points, you're just going to take the length of the period after you calculate it and then quarter it. And we're all going to start counting by fractions. Now I know for some of us, when we learned how to graph these back in Algebra 2 in particular, we were taught to like take the period, cut it in half, and cut it in half again. Okay, and that's okay. The problem is when we start phase shifting, that doesn't really work very well. So I'm going to step away from that idea, and we're going to go strictly to like finding a quarter point. When we have phase shifts next week, the thing that trips kids up are the fractions, because I mean, you think about your favorite radian measures, they're usually funky. So then when I ask you to like take pi over 6 and add pi over 4 to it, you're like, great, because that means I have to work with fractions. So we'll get around the fractions. That's not a big deal. All right, this is not on your notes yet because everything got reordered. I think the first thing you guys see in your notes as far as problems, it's called 7 here, but I think it's number 1 on your notes. Does that look right? Awesome. Okay, so you are going to be asked to graph this. I am not providing you anything. So you're going to do the best you can to graph, and if you graph like me, you got to kind of help yourself out. So first thing I'm going to need to do, I'm going to need to draw some lines. Okay. That's not a line. I thought it was going to fix it for me. Don't they usually fix it for me? Oh well, I'll use a shape tool. No, shape pen. What is it called? Shape pen. There we go. Line. Nice. Line. Nice. That was magic, wasn't it? That's so good. I totally did that by hand. I like to draw amplitude lines in, which basically restrict my graphing because I need all the help I can get. So the midline on the next few questions we do is not going to shift off of 0. All of these are going to have plus nothing off to the side. So your midline is going to stay at 0, but your amplitude, absolute value of 2 is 2. So you're going to have a upper line here at up 2, and then where's your lower line here going to be labeled at -2. So let me use something that'll help me because I can't draw. Oh, it's supposed to fix it. Why is it not? No! 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 I don't know what just happened. Oh, come on. It's never made me draw straight before. It's always accommodated my lack of... Okay, here we go. I'm going to focus. I'm going to square my shoulders up. Maybe it's because I have like an already gifted line. It's like, you know what? You don't get any more help. Oh my gosh. It's like getting worse and worse. Okay, here.
Oh boy. You just stopped yelling.
I know. I think the crooked green lines are better. All right. Anyways, that's 2. And that's -2. So here's what you can feel good about. If you look better than that, you're better than me. So I'm not going to be too picky about it. In hindsight, I should have pre-drawn some things for myself. Oh well. Okay. You guys talked to me about, and this one's right away, it's got a weird one. What's going on inside of this cosine function? Because I don't really like the way it's written. We don't usually say theta divided by 4, because usually the letter b, the variable b, is in front of the theta. So can't we just rewrite that as like 1/4 theta? Okay. So what that means is your b value, which is this number that's going to change the length of the period, is 1/4. So the period is no longer 2 pi. It's 2 pi divided by b, so 2 pi divided by 1/4. All right, then I got to go back to 4th grade for a second. Remember how we divide fractions. We multiply by the reciprocal. So the period is actually 8 pi. Now, for these basic graphs, that means my first cycle will end at 8 pi. But to get in good habit, let's talk about finding the quarter point. What you do is you take the entire length of the period and you quarter it. So 8 pi divided by 4, better known as 2 pi. So for this problem, that's going to be significantly easier than the ones coming up next week. You just start at 0 and you start counting by 2 pi's. So here's 0 radians. We're going to have 2 pi. Keep counting with me, y'all. 2 pi, 4 pi, 6 pi, 8 pi. And by the time you hit the 5th x value, that should be the end of the first cycle, which is 8 pi. Now, kind of envision next week, guys. If you're not starting at 0, this gets a little more confusing. All right, here we go. All you need to remember for me is where cosine starts. Yep, up at the maximum. So 0 radian starts up here at 2. Boom. And then I just play connect the dots as best I can. Let's see. I've been bragging a lot about my trig function graphing today, and so far I've not really executed it. Hey, I'm going to call that a win. It has the general shape of a cosine curve. Go me. All right, here we go. Now, you're PreCalc. You're better than this, guys. You can label ordered pairs with me, too. This is, yeah, just drawing a weird little horseshoe thing isn't going to work anymore. You got to give me the ordered pairs. What's this ordered pair up here? 0, 2. What's this ordered pair? 2 pi 0. Yeah. Flip that around for me. 4 pi -2. What's this guy? Yeah. So I'm purposely identifying the ordered pairs that I already identified because I'm lazy. All right, 8 pi comma 2. That identification of the ordered pairs is so important when we start phase shifting because that gets hard. All right, good deal, good deal. Let's look at number, it's really number 2, not number 8. All right. I feel like pausing the video until I can get a good graph. Do you think that'll help me? I wonder if I don't use the shape tool on the first part. I didn't use the shape tool. Don't judge. Maybe, I don't know. Don't judge. See? Just leave it. Just leave it. I don't even care anymore. All right, so the midline is 0. The amplitude is 3 units up and 3 units down, so whatever. As long, see, here's the thing. As long as you label it right, it doesn't really matter what your graph looks like. Well, that's not true. Should have the general shape. All right, let's calculate the period. Inside the sine function, it says it's 2 times theta. So the period length is no longer a normal 2 pi. It is 2 pi divided by 2, which means the period length is pi. Which also means that when I go to quarter up the length of the cycle, you take that period and you divide it by 4. We're just counting by pi over 4. So starting from 0, I'm going to go 1 pi over 4. What's next? Yeah, and I'm okay if you write down 2 pi over 4 for now, and then you come back and simplify it later. The point is you do at some point have to simplify it. What is 2 pi over 4? Pi over 2, good. 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4, which is pi. So yeah, fraction work, if that's where you kind of get tripped up, don't reduce them until you're done filling everything out, and then come back and reduce them. All right, so remember this time you're graphing sine. Sine function starts at the origin, 0, and then goes up yonder, and back to the middle, down to the minimum, back to the middle. See, I told you I could graph, kind of, within my crooked lines. What are these ordered pairs? 0, 0, pi over 4, 3. What's this guy? Pi over 2, 0, good. 3 pi over 4. Negative 3, thank you. And pi 0. Whew. Lovely. And then let's end our day on a nice one. Let's look at number 3. Also known as number 9 for me. All right. First question is a trick question. What is the amplitude? Oh man, I can't even trick you. Okay, it is 1/2. I was kind of hoping you'd say negative 1/2 so I could yell at you. Because we know amplitude is not negative. Amplitude is the size of the wave. So it's kind of like an absolute value question. And yeah, I don't even know if I should bother. It's pretty good. I don't want to ruin it now. But it's not centered. All right. I think I can move it. Should I?
Okay.
You all held your breath when I did that. You're like, she's going to screw it up again. All right. Cool. So midline still at 0. This is a 1/2. This would be a negative 1/2. And of course we got to end the note on a horrible, oh, gross. B value is 3. So what's the period? 2 pi over 3. Oh boy, here we go. Now you got to quarter that for me. So when you take a fraction, already a fraction, and you try to divide it by 4, another way to do that is to multiply by 1 over 4. So do a little simplification for me. This is 2 pi over 12, better known as pi over 6. You are going to be counting with me by pi's over 6's. Alrighty. 1, 2, 3, and 4. Here we go. 1 pi over 6. What's next? Okay, you can say 2 pi over 6. What does that reduce to? Pi over 3. Good. 3 pi over 6, better known as pi over 2. Thank you. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, better known as 2 pi over 3, which, oh, thank goodness, that's where I was supposed to end, was the end of the period, 2 pi over 3. Okay. And then I heard someone whisper something about a reflection. What are they talking about? You already drew it, didn't you? That'll teach you to work ahead of me. All right. So there's been a reflection. So instead of this cosine graph starting at the maximum, this one's going to start down here at the minimum. There we go. And yeah, sure. Why not? Oh, I missed the point. See all that work with my, oh gosh, it just got worse and worse. All right, so that was supposed to not look like that. That was really bad. So knowing you guys from the last semester, I'm going to assume that you are not going to work on homework for worksheet 11 yet. Technically, you guys can start on worksheet 11. It is not due until the next homework check. So I would like you to focus this weekend on completing your current homework check, which is technically due Tuesday. Because that's what your summative is on. Now, on Monday, we're just going to continue with the graphing lesson. I might have a few minutes to answer questions on the purple review, but we're not going over that purple review at any point, and there's no video. And if there's mistakes on my key, please let me know, and I'll try to fix it. I'm sure there's a mistake. Oh, yeah.